So we can also use a tool to monitor the trajectory of a point on certain link. So for example, if I want to know the trajectory of a point on this link, you can click trace. So I click a trace and you can determine the point that you want to trace. So here I determine this one. So you will see this one is highlighted and you click the default. There are some options here. So in this one, it means it will displace the trace just on this this space. If you click the options on this column, then they will appear in the output grapher. So we will do that later. So let's just check this one for now. So once you check this one and you run the simulation, you will see a new curve appear here. This curve just representing the trajectory of a point I just selected. So right now you can open the output grapher, and here you will find an option called traces. You just click it, and this trace is the one we just generated. You can modify this one because right now maybe you want to know the position, velocity, or acceleration information about this trajectory, about this point. So you can click those options, click those boxes, and then check OK. Then they will just appear below the trace number 1. So here you can see the position information of this trajectory. So here you can see the component shown here is called X, Y, and Z. So those components are based on the global coordinate. So X, let me rotate to this view. So X is in the horizontal direction, Y is in the vertical direction, and the Z direction is pointing in or pointing out of this surface. So here you can see the position in the X direction or position in the Y direction. You can also see the velocity in the X and in the Y direction. Let me cancel the position. So those are the velocity. And of course, you can also see the acceleration in the X and the Y directions. You can also check a Z direction, but they are supposed to be 0. So by using trace, you can find the motion of a certain point on a link. You can also use trace to help you to determine certain variable that's not provided by the original output grapher variables. For example, I want to determine the angle of this link, this blue link. And you can check those options, but you couldn't find an option that determines the absolute angle of this blue link. But we can do it with trace. So if I can determine a point, 2 points on this link, then I can use the relative position of these 2 points to determine the angle of this bar. So let me do it. So I'm going to determine a trace, number 1. And I need a position information. So here I choose this point, and so right now the position of information about this point is provided here. And I'm going to determine another point on this link. And determine this point, click the trajectory. So adding this this trace, it just brings another position information of another point. And then once this is done, then I'm going to create user-defined variables to help me to determine the angle of this link. So here you can move this one. There's an option called new curve. So click this one and assign a name for this new curve. I'm going to call it theta 3. So theta 3 is going to represent the angle of this link. So I'm going to do the arctangent of the arctangent, and I'm going to add the y component of this point minus the y component of this point. So trace and minus this y component, and then divide the x component. So the x component of trace 2 minus the trace component of a minus 1. The x component of trace 1. Let me check if there's any. Okay. Equation is valid. New curve. Oh, sorry, I already have a theta 3, so I need to delete that one first. So I need to cancel it. So I generate. Sorry, I already have a theta 3, so I need to create a new one. So anyway, I just copy the equation I typed before and name it a theta 3. So this theta 3, you can see the equation is the y component of this one minus y component of this one, and over x component of this one minus x component of this one. So this should give me the information of theta 3. So once you click OK, it will just automatically check the theta 3. And the theta 3 is from minus 30 degree to minus 23 point something. And you can see, yeah, that's exactly the value we want. It's currently minus 30. When the time is increasing, then the angle is reducing. Then going back to 30, then just move back and forth. So sometimes if you couldn't find an option that to determine your desired output, you can use this method. You can add some trace point to help you to determine your desired output, velocity, position, or etc.